In the previous video, we talked about what a rectangular coordinated system is. And we also looked at an equation, y equals 3x plus 2. And we showed you what the solutions would be like. And we can pick one number for pick a number for different numbers for the variable x or for y and solve for the other one. And as we can see, we can get infinite many solutions. And for each solution, each pair of solution, again, that's first column is the solution for x, second column is the solution for y. For each solution in the coordinate system, we're going to get a point. And those infinite many solutions will give us infinitely many points in the coordinate system, and all these infinitely many points will form a straight line. And so there are two different ways to look at this equation. One is the algebraic view, and the other is the geometric view. It's a straight line. So now let's look at continue to look at some more examples. If we still look at this example, 3x plus 2. Now it's a two-variable equation. Two-variable equation. And we're going to, this time, instead, we're going to give you some ordered pairs. Say we have 2, 8, it's an ordered pair. And another pair is 3 and 10. Another pair is -5 and -13. We want you to check whether each pair is a solution. So how do we check that? All we need to do is to plug the numbers into the equation to verify whether it will satisfy the equation. And remember, the first number is always represents the x coordinate or a value of solution for x. And second number is y. So in this case, it means x, we're going to replace that x with the 2, replace that y with the 8. And let's verify, let's check. So I'm going to copy down equal and copy down the 3 and times and copy down the plus sign and 2. Now we can verify that the left side 8 is equal to the right hand side because 3 times 2 is 6. 6 plus 2 is 8. So that is correct, which means this is a solution. And let's check the second pair, 3, 10. So we're going to replace, this time we replace y with, that's our x, that's our y. Replace y with the 10. And replace the x with 3 and plus 2. Notice that 3 times 3 is 9. 9 plus 2 is 11. So the right hand side we add up to multiply and add up to 11. And it's not equal to 10. That tells us this is not a solution. Now let's look at the third pair. And that's our x, that's our y. So replace y with -13 and replace x with -5. And we have 3 times -5, that's -13, -15. And then -15 plus 2 is equal to -13. So that is also correct, which means this is also a solution. So we found out, yes, this is a solution. This is not a solution, and that is a solution. Just like when we solved the equations before, we got x equals something, and we can plug the number back into the equation to verify it is the solution. But if you plug back into the equation, it doesn't give the equal sign, and then it's not the solution. So it's similar, but we need to plug in two numbers into the originally. One number for x, one number for y. The second type of question is graphing. So when you are given an equation, how do you do the graphing? We did do the example before for y equals 3x plus 2, so we can look at another example. Now we can do, say, 3x minus 1. And it doesn't matter if they give you a table or not. When you draw the graph, sketch the graph, you will have to make a table. You may be able to do it in your head, but it's still better to write down the table. So create a table for x and y. Because in order to draw the graph, you have to have solutions for this equation. And so you can draw x-axis and y-axis and to sketch the graph. So first let's and when you so we need some points. How do we get the points? The points will come from the solutions of this equation. So let's pick some values for x. Suppose they give you some, even if they just give you some values, say x equals 1, x equals 0, and x equals 2, or maybe we can pick a negative 1 and try to get some values for y. Okay, so if x equals 1, we do 3 times 1, 3, minus 1, we get a 2. If x equals 0, 3 times 0, 0, 0 minus 1, negative 1. If x equals 2, 3 times 2, 6, 6 minus 1, 5. If x equals negative 1, 3 times negative 1, negative 3, minus 1, negative 4. So we got these 4 pairs, each pair. So the first pair, 1, 2. Let's put that point, plot that point. So x equals 1, y equals 2. We got this point right there. X equals 0, y equals negative 1. So x is 0, y go down to negative 1, the second point. And let me use a different color too. So this first point, second point. Third point is 2, 5. When x equals 2, y equals 5. So 5 is way up there. 3, 4, 5. So we're going to get a point up there. And negative 1, negative 4. When x equals negative 1, we go down. Negative 1, negative 2, negative 3, negative 4. So my graph is not really perfectly scaled, and so it's just a rough picture. So now we get these 4 points, and we know that, so this is sort of given that if you have 2 variables and with x and y, no squares, and the graph you're going to get, it must be a straight line. We didn't pick more points. You can continue to do that, but if you give an assumption that this must be a straight line, and that should be enough points to give us a straight line. So we connect those points to get the graph. So this line represents this 2 variable equation. So let's look at another example of more graphing. In this equation, it's not written in the form we had before, y equals something, but still it has 2 variables, x and y, and it also has an equal sign. So this is also a 2 variable equation. So we're going to introduce a new concept called x-intercept and y-intercept. X-intercept is, so we know this after we sketch the graph, we're going to get a straight line. And we can go over the previous example. So the straight line, as you can see, it cuts the x-axis right at this point, and it cuts y-axis right at this point. So this red line intersects the horizontal line at this point and vertical line at this point. And these 2 special points, we have names for this. For the intersection point with the x-axis, horizontal line, we call it x-intercept. And the point on the y-axis, we call it y-intercept. So this one is called y-intercept. Why are these 2 special? Of course, because first of all, because they lie on those, the one lies on the horizontal line, one lies on the vertical line. Another special thing is we know that any point on the x-axis or the horizontal line, and because it's not moving up or down, the y-axis must be 0. So sorry, y-coordinate must be 0. So this x-intercept, this point right here, we don't know what the x-coordinate is, but we know for sure the y-coordinate is 0 because it's not up and down. And for this point, we actually have an answer right here. It corresponds to this point, 0, negative 1. So we really know this number is negative 1. But as you can see, because it falls in the y-axis, the x-coordinate is 0 because it's not going on the left or going to the left or right. So the x must be equal to 0. So the y-coordinate, actually, we found it out, it was negative 1. So these are special properties about things about the x-intercept and y-intercept. So x-intercept, because it's on x-axis, it must have y-coordinate equal to 0. Similarly, the y-intercept, because it falls in y-axis, so the x-coordinate must be 0. So if we remember these, and we can solve for x-coordinate and x-intercept and y-intercept. So if you remember, x-intercept, the y-coordinate must be 0, and y-intercept, x-coordinate must be 0. So we can plug the values in here. How do you solve for x-intercept? We replace y with 0 because y must be 0. So we have 3x plus 0 equals 5. And solve for x equals, divide both sides by 3. So we get 5/3. And similarly, to solve for y-intercept, because x must be 0, we replace this x value with 0. 3 times 0 plus y equals 5. And because 3 times 0 is 0, we end up with y equals 5. So this value here is called x-intercept, and this value here is called y-intercept. That's how we look for x-intercept and y-intercept. So this time, I can still make a chart, but if you don't make a chart, that would be okay. So when x equals 0, y should be 5. When x equals 0, y is 5. And when y is 0, x is equal to 5/3. So with these two values, that's good enough to sketch the line. And also you can do it by definition. Like I said, you may not need this table because this is x-intercept, 5/3. 5/3 is approximately 1 2/3. So we're going to have somewhere the point right here. Use a different color. So that's the point, because x-intercept must be on x-axis. And so this is the first one. And y equals 5, because y-intercept must be on y-axis. So 5 would be 1 2 3 4 5. So we have these 2 points, and we can join them and to get a straight line. So that would be the graph. For my line is not perfect, not straight, but so you get the idea how to do that. So these 2 points right here, this point on the x-axis, 5/3, it's called x-intercept. And the other one on the y-axis, right here, it's called it's called y-intercept, because intersects the straight line intersects x-axis and y-axis. So you can just by setting x equal to 0, y equal to 0 to solve for the other one to get just these 2 points. That will be enough to sketch the graph. So more examples for graphing. As we already know, when you have 2 variables, x, y both have degree 1, then it must be the graph must be a straight line. So we can make a table, and the straight line, we know 2 points will determine a line. So when we now pick numbers, I can just pick 0 for x, solve for y. So I can skip that step here. So when you replace, and y is going to be a negative 1/4. I'm sorry, y is going to be equal to 0. But if I pick, let's say, 1 for x, and then I'm going to have 5 minus 4y equals 0, and the y is going to be equal to 5/4. So with these 2 points, that's good enough to sketch the graph. So first point is 0 0, which is at the origin. The second point is 1 4/5. And then join these two, you can get the graph for that. Now there are special cases like this. What if there's no y or no x? So when you don't have y or x, that just means y can be anything. So for example, here we don't have y, which means y can be any value, but x will stay the same as 3, and y could be 0 or 1 or 2. So we will have the graph, these 2 points, 3 0, when x equals 3, y equals 0. Another one is when x equals 3, y equals 1. So we got these 2 points, 3 0 and 3 1. And when we join them, we get a vertical line. And similarly for y equal to 0, that means y always stays at 0. Doesn't matter what x is. So you have 1 and 2 here. And when you sketch